This is going to be a video on how I made these models for um, bracketry for rod ends and how I designed them parametrically in order to manufacture them and not have to make a bunch of changes to the model. So basically what I did, I'll pull up a sketch here. Pull up sketch 1, I suppose. Let me close this window. So this sketch right here, all of these ones that have a function determining the value on there, those are all parameters. So what you can do is you go up to change parameters in modify, and you have to have I think you have to have history capture on for your design history. But anyways, you can input different values for these different measurements. So say I want that bore, rod end bore, which is this one right here. Say I want it to be 3/4. I could put 0.75. It would automatically update the drawing. I'm going to put that back to what it was. But you can see the model, the physical solid model, is based off of that drawing and those measurements. So when you have design history on, you can basically change the solid model with those parameters. So that makes it a lot easier for making tweaks to the model. Unlike 3D stuff that isn't necessarily seen in a 2D sketch, you can change and add as a parameter here. So like this fillet right here, I can go to edit feature on the history, and then I have the fillet function in there, so that's in my parameters as the value for the fillet. So I just leave that. But anyways, this makes design and making changes a lot easier after the fact. I definitely recommend it, and especially if you're making parts that are like these are rod end brackets. They're going to be fit to different size tubes and also different size rod ends. So I can make changes to fit those different rod ends in tubes, and then pull up my manufacturing workspace and update all my tool paths, and it'll automatically update if you set your tool paths correctly. So you have to set your tool paths off of geometry that updates with your sketch or your model. So that can be kind of tricky, but it's easy to kind of figure it out. But it's just honestly a really nice way to get consistent parts and be able to make changes to them across the board. So right now I have my setup 1. I usually run 2 parts on my setup 1 and 1 vise. But right now I'm just going to run 1 because that's how I have the stock cut. And I have my WCS right here on the bottom back of the vise. So that will be our G54. And then on setup 2, I'm just going to use the same point on the vise, but usually I'll run 2 vices and have this be a G55 and just set another work coordinate offset for that. And then it'll machine the rest of it. So it's honestly pretty intuitive. I like the way Fusion has it set up. Yeah, so we'll get started here. Make sure everything's good. I have this step down kind of conservative because it is steel. I mean, I'm not super used to steel yet, so we're still kind of working on it. But anyways, I got a clearing and then a contour And then I have this contour, which is basically a facing operation, and it gives it kind of a cool pattern on the side there, which, I mean, aesthetically it's really pleasing. I like it. And then another clearing with tool 2, which is a 1/4 inch flat end mill. And then contour, a scallop, which is a 5/16 ball, and then a chamfer, which is, I think I'm using a 1/2 inch spot drill, which I should probably be using a chamfer mill, but whatever, it works. So, and then this setup, I think it's pretty much the exact same thing, just different geometry selected. Alright, so excuse the mess and the extra noise, but I got my stock right here. It's a 2x2x3 steel, 1-1/8 mild steel. What we're going to be doing is setting up a vise and then basically indicating it in, making sure it's even with the spindle, and then we're going to be setting our G54 WCS with Heimer. If you haven't seen these tools, they are very useful, especially if you don't have like a probe system or something like that. My machine's a little old, so I don't have that, but they are basically a dial indicator that reads every which way, and even up and down in the Z. So you can basically set your X, your Y, and your Z with it. It's super useful. I'll never go back to an edge finder. I just find they're a little too unreliable for me. But anyways, I'll set up the vise and we'll get going. Looking pretty good. Now what we're going to do is we're going to set our Z off the top of the 1, 2, 3 block. This block is precision ground, so we know it's actually an inch. So once we get our 0, we'll make our WCS an inch lower than this point. Alright, so got our position, and we need to make it an inch above the part. So we're going to put in 7.2381, which is an inch above the part. And I think we have our WCS now.